In this section, we are going to discuss about the architecture of mobile telecommunication system. So we already seen or discussed something about basics of communication technologies, mobile handsets, wireless communication and server application. Then types of telecommunication networks, voice network and data network we have discussed there. Then computer network, controller area network, local area network, internetworks, etc. Then the structure of an internet, followed by a LAN architecture specified there. Then components of a wireless communication system, so transmitter, receiver, antenna, filters, amplifiers, mixers, all these are some of the components of a wireless communication system. Now we are moving on to architecture of a mobile telecommunication system. A simplified architecture of mobile telecommunication system has been shown here. It has three main components: the core network, the radio access network, and the handheld devices like mobile phones. The core network is specified in dotted lines. That box with dotted borders are specifying the core network. So architecture includes mobile handsets communicate over the radio access network. The radio access network is primarily composed of the base station which communicate with the mobile phones using radio frequency electromagnetic waves. The coverage area is structured into hexagonal cells. In a hexagonal cell, one base station is located. Two types of radio channels are usually involved in the communication between a base station and the cell phones: control channels and voice channels. Control channels typically use frequency shift keying or FSK and are used for transferring control messages between the mobile phone and the base station. As specified in the slide, the second type of channel is voice channel. Voice channels typically use frequency modulation or FM. A base station typically has two antennas of different characteristics. One antenna is used for receiving and the other for transmitting. Use of two different types of antennas at base station increases the ability of the base station to receive the radio signal from mobile that use very low transmitter power levels. On the other hand, mobile handsets typically use the same antenna for both receiving and transmitting. As shown in the figure, the core network interconnects the base stations, the mobile switching center or MSC, and also provides an interface to other networks such as the traditional telephone network, that is PSTN, public switched telephone network, and also with the internet. The interconnected network or the interconnect used in the core network is required to provide high speed connectivity. Therefore, fiber optic cables are usually used as the backbone interconnect in the core network. In difficult terrain conditions, microwave communication can also be used. The interconnection in the core network must allow both voice and control information to be exchanged between the switching system and the base station. The MSE, that is the mobile switching center, is connected to the landline telephone network to allow mobile phones or mobile telephones to be connected to standard landline telephones. The core network is responsible for transmitting voice calls, short message service or SMS, etc. from one phone to another through switches. The core network also maintains a database that contains information about the subscribers and the information about billing. The next thing is what we are going to discuss is mobile or wireless networking standards. Wireless networking standards. Standardization is very important to the computer networking domain since many protocols and devices need to interoperate in a practical networking solution. Further, there can be various vendors manufacturing the network equipment. In the absence of appropriate standards, it would become interoperate the product manufactured by different vendors. Mainly, three international standardization bodies are responsible for formulating networking standards, that is ITU, IEEE, and ISO. The IEEE or Institute of Electrical and Electronics Engineers is non-profit technical professional association of members from over 150 countries. IEEE acts as a standard body. Standards are very important in networking since multiple devices that are often heterogeneous and manufactured by different vendors need to communicate. IEEE proposes standard for new technologies and maintain all standards. IEEE created the 802 group to help standardize the LAN technology. 802.3 standard from this group defines the requirement that the product must meet for it to be considered Ethernet. Wireless Ethernet is defined by 802.11 and 802.11 is further broken down into more specific certifications such as 802.11a, 802.11b and 802.11g. Each of these defines a different method for providing wireless Ethernet. Each protocol specifies various aspects of data transfer that distinguish it from the other protocols. 802.11 standards define rules for communication on wireless local area network or wireless LANs. 802.11 was the original standard in this family, ratified in 1997. 802.11 defined wireless LANs that operate at 1 to 2 Mbps. This standard is obsolete today, but its extensions are being used extensively. Popular extensions of 802.11 standard include 802.11a, 802.11b, and 802.11g. Each extension to the original 802.11 appends a unique letter to the name. For example, the standards 802.11a, 802.11b, and 802.11g define different types of signal modulation and frequencies of operation. So, in our figure, the following some of the 802.11 standards are being used for wireless local area networking. So here IEEE 802.11, the data rate is specified here as up to 2 Mbps in the 2.4 gigahertz band. This specification has been extended into 802.11b. And the second standard, that is IEEE 802.11a for Wi-Fi, that provides a data rate up to 54 Mbps in the 5 GHz band. Standard are considered Wi-Fi certified. 8 available channels, less potential for radio frequency interference than 802.11b and 802.11g. Better than 802.11b at supporting multimedia voice, video, and large image applications in densely populated user environments. Relatively shorter range than 802.11b, not interoperable with 802.11b. The next standard is IEEE 802.11b, that is also for Wi-Fi, that provides a data rate up to 11 Mbps in 2.4 GHz band. Products that are adhered to this standard or 802.11b standard are considered Wi-Fi certified. not interoperable with 802.11a, which requires fewer access points than 802.11a for coverage of large areas, offers high speed access to data at up to 300 feet from base station. 14 channels available in the 2.4 GHz band, only 11 of which can be used in the US due to FCC regulations, with only 3 non overlapping channels. 802.11g up to 54 Mbps in the 2.4 GHz band, that is the data right here for 802.11g. Products that adhere to this standard are also considered Wi-Fi certified. May replace 802.11b, improved security enhancements over 802.11. Compatible with 802.11b, 14 channels available in the 2.4 GHz band, and only 11 of which can be used in the US due to FCC regulations, with only 3 non-overlapping channels. And the next one is 802.16. So that is WiMAX. That specifies WiMAX in the 10 to 66 GHz range, commonly referred to as WiMAX or less commonly as wireless MAN, for the air interference standard. IEEE 802.16 is a specification for Fixed Broadband Wireless Metropolitan Access Network or MANS. IEEE 802.16a. Here it added support for the 2 to 11 GHz range, commonly referred to as WiMAX or less commonly as wireless MAN, or the air interference standard. IEEE 802.16 is a specification for Fixed Broadband Wireless Metropolitan Access Networks or MANs. Then comes Bluetooth. So that gives a data rate of 2 Mbps in the 2.45 GHz band. No native support for IP. So it does not support TCP IP and wireless LAN applications well. Not originally created to support wireless LANs, best suited for connecting PDAs, cell phones, and PCs in short intervals. Then HyperLAN 1 that is available in Europe. The data rate is up to 20 Mbps in the 5 GHz band, only available in Europe. HyperLAN is totally ad hoc, requiring no configuration and no central controller. Does not provide real isochronous service, relatively expensive to operate and maintain, and which does not provide any guarantee for its bandwidth. HyperLAN 2 up to 54 Mbps in 5 GHz band, that is the data rate, only available in Europe, designed to carry ATM cells, IP packets, firewall packets, that is IEEE 1394, and digital OIS from cellular phones. It provides better quality of service than HyperLAN 1, and it also doesn't guarantee bandwidth. The next standard name is OpenAir. It is a pre-802.11 protocol using frequency hopping and 0.8 and 1.6 Mbps bit rate. OpenAir is the proprietary protocol from Proxim. All OpenAir products are based on Proxim's module. So Proxim is a vendor or company. Some other IEEE standards are 802.11c, operation of bridge connections, and which is moved to 802.1d. 802.11d, worldwide compliance with regulations for use of wireless signal spectrum. 802.11e, quality of service support. 802.11f, inter-access point protocol, recommendation for communication between access points to support roaming clients. 802.11g, 54 Mbps standard, 2.4 GHz signaling. 802.11h enhanced version of 802.11a to support European regulatory requirements. 802.11i security improvements for the 802.11 family. 802.11j enhancements to 5 GHz signaling to support the Japan regulatory requirements. 802.11k wireless LAN system management. 802.11l L skipped to avoid confusion with 802.11i. 802.11m maintenance of 802.11 family documentation. 802.11n 100 plus Mbps standard improvements or 802.11g. 802.11o that is not available, that is skipped. 802.11p wireless access for vehicular environment. The next 802.11q is skipped, that is not available. Q is not available. 802.11r fast roaming support through basic service set transitions. 802.11s provides ESS mesh networking for access points, and 802.11t wireless performance prediction recommendation for testing standards and metrics. And 802.11u is there, that revision or version gives internet working with 3G or cellular and other forms of external networks. So these are some of the IEEE standards and its features. If you have any doubts, you can please ask me. Thank you.